Hi guys, good morning. This is a video. It's going to go through version B of your practice quiz for Unit 4, and that's dealing mostly with stoichiometry. So first we're going to name the polyatomic ions. I'm going to go through this video a lot faster than the last one. This polyatomic ions, you only have to know 6 polyatomic ions. SO4 2- is the sulfate ion, and NO3 1- is the nitrate ion. CO3 2- is the carbonate ion. You can go from the formula to the name, or as we do down here, from the name to the formula. So the phosphate ion is PO4 3-, the hydroxide ion is OH 1-, and the ammonium ion is NH4 1+. Memorize these. I have a bunch of resources on Moodle for naming, and it will also have your polyatomic ions within those names. Use those resources, make a little flashcard or flip sheet to memorize your polyatomic ions. No tricks to naming them, just memorize them. Balance the equations. We have a combustion reaction, C4H10 reacting with oxygen to produce CO2 and water. That is the telltale sign of a hydrocarbon combusting with oxygen. 4 carbons on the left, so we put 4 carbons on the right. 10 carbons on the left for the hydrogen, so we put a 5 here because there's a 2 right there. 5 times 2 is 10. Now there's 5 hydrogens on the right. 5 oxygens, 5 times 1 oxygen plus 4 oxygen is 9. 9 divided by 2 is 4.5, so I put 4.5 here, but you cannot leave a decimal in your coefficient. So we multiply everything times 2. There's an understood 1 here. That gets canceled out as well. And what happens is we get these new coefficients, 2, 9, 8, and 10. Those are your new coefficients. Alright? These other ones get canceled out. And I'll just put 2 lines through those so you can see that they are canceled out. And you can even highlight these, right, to make sure you know that those are the real coefficients for that balanced reaction. Alright, let's keep on going. We balance this. Magnesium plus oxygen gives you magnesium oxide. Super easy. 2 oxygens on the left, 2 oxygens on the right. So now we need 2 magnesiums on the left. Another combustion reaction. This one, again, we'll probably have to use the decimal, so 5 carbons. Now we have an oxygen here. We'll take that into account later. 5 carbons on the left. We put a 5 here for 5 carbons on the right. 12 hydrogens, so I put a 6 here. 6 times 2 is 12. Now, how many oxygens are on the right? 6 plus 10. I have 16. 16 divided by 2 is 8, so you'd be tempted to put an 8 here, but you can't do that because we have 16 oxygens here, and you have 3 over here, so you only need 13 more. Okay, so 16 minus 3, so you need 13 more, right? So what I do is I say 16 minus 1, because this is this oxygen here. So that equals 15. 15 divided by 2 is 7.5. So I put a 7.5 here. See, because I had the oxygen here, I had 16 on the right, I had 16 minus that oxygen, and then 2 divided by 15 is 7.5. Now I can't leave that decimal, so what I'm going to do is I'm going to do the same thing as I did before. I'm going to cross out each one of these coefficients, and I'm going to put a new coefficient in its place. When I multiply everything times 2, this becomes a 2, this becomes a 15, this becomes a 10, and this becomes a 12. And I'm going to highlight that again, just so you know that these are the coefficients for that balanced reaction. Alright, we keep going. We move down here, we got potassium sulfate reacting with lead 4 acetate to produce potassium acetate and lead 4 sulfate. So here we go, we got 2 potassiums, so I'll put 2 potassiums over here. But even before I do that, I notice, I say, wait a minute, there's 4 acetates. If I put a 2 here, I'm going to need to double that. So I'm just going to put a 4 here right away. I put a 4 here because these 4 acetates, see this ion? That is the same as this anion right there. So now there's 4 potassiums. I'm going to put a 2 here. Now I have 2 times 2 is 4 potassiums. I also have 2 sulfates, and I also have 2 sulfates. I have 1 lead, and I have 1 lead. We are balanced. This is a double replacement precipitation reaction. Combustion, here and here. This can also be classified as combustion or as synthesis. We're not going to do reaction types for this unit, but we will in January. Write out the following equations, then balance them. Iron 3 nitrate. Iron is Fe. Nitrate is NO3, 1 minus. If this is a 3, that means it's a 3 plus. The nitrate is 1 minus. The 1 comes down here, the 3 comes down there, and there is iron 3 nitrate. That is aqueous. We'll learn that in January. Sodium carbonate. Sodium is 1 plus. Carbonate is CO3, 2 minus, the 2 comes down here, the 1 comes down there, so this ends up being Na2CO3, which is also aqueous. Then what we produce for this reaction is iron 3 carbonate. Iron 3 carbonate, that means we have a 3 plus and a 2 minus, the 2 comes down here, the 3 comes down there. This ends up looking like this. And that is a solid. We will talk about that next unit. I'm running out of room. Let's see if I can extend this. I can. Beautiful. Oh, never mind. And let's try it one more time. Okay. Oh, okay. Never mind. So we'll have to adjust here. So our other product is sodium nitrate. I'm going to erase those two lines. I'm going to write it very small. Sodium nitrate. Sorry about that sloppiness. I'm going to try to write it even smaller. Sodium nitrate, and that is aqueous. And now I'm going to balance this reaction. So I'm going to change ink here. I have 3 nitrates and I have 1 nitrate. So I'm going to put a 3 here. But before I do that, I noticed something. I have 2. Oops, I made a mistake. Some of you might have noticed that I made a mistake in the video. I said there was going to be 2 carbonates, but actually there's 3 carbonates. So I caught my mistake. If we make mistakes, it's okay. We just erase them, start over, or we catch them and just correct them. So 3 carbonates on the right, there's only 1 carbonate on the left. I'm going to put a 3 here. Now I have 6 sodiums, so I'm going to put a 6 here for the sodium. I have 2 irons and only 1, so I'm going to put a 2 here for the iron. Now I have 6 nitrates, and I have 6 nitrates. We are balanced. Let's scroll down here, and let's do dinitrogen trioxide. So let's try that. We have N2O3. That would probably be a gas, but it could be a solid. I really don't know, to be honest with you. Sulfur dichloride, sulfur, monosulfur, dichloride. We don't say the mono because it's the first one, but there's one of them. Dichloride, that would probably be a, I'm guessing a gas, but again, I really don't know. I think it would be a gas. Sulfur monoxide, that would definitely be a gas. And this nitrogen trichloride, NCl3. So let's try this one. I have 2 chlorines on the left, I have 3 chlorines on the right. We need to find a common multiple. The common multiple will be, as you guessed it, it will be 6. Let's put a, this will probably be a, I think it would be a solid, but again, I don't know. We can put it as a gas for now because everything is a gas. This might be a gas, maybe. Not important to balance it. We're going to find a common multiple, and the common multiple is 6. So there we go. Now we have 6 chlorines on each side. Look at this. Now I have 2 nitrogens. Awesome job. I have 3 sulfurs. So I have to put 3 sulfurs. Now I have 3 oxygens, and I have 3 oxygens. We just balanced it. Hooray. Now I move down to the next page. I got to move this over. There we go. So here we go. Now, given 0.0250 grams of lead 2 nitrate, calculate the number of moles of lead 2 nitrate. First thing I'm going to do is I'm going to write out, stop. I'm going to write out, once this stops enlarging and my computer catches up, I'm going to write out lead 2 nitrate as a formula. Okay, seriously. Okay. And then, there we go. Alright, so here we go. Yeah, computer's a little bit slower than I am, but that's okay. So now when I write out lead 2 nitrate, any minute now, this is going to happen. Okay, when I write out lead 2 nitrate, what it looks like is this. I have lead, and I have, yeah, that's fine, and I have nitrate. Nitrate's 1 minus, lead is 2 plus, it tells me right here. So I put the 2 here and the 1 down there. There's lead 2 nitrate. I find the molar mass for lead 2 nitrate. And the molar mass for lead is Pb 207.19. So Pb equals 207.19 grams per mole. I have 2 nitrogens. Nitrogen equals 14 grams per mole. I'm going to multiply that times 2. Oxygen, I have 6 of them. Oxygen equals 16 grams per mole. I'm going to multiply that times 6 because I have 2 times 3, which is 6. When I multiply that times 6, I get 96 grams. When I multiply 2 times 14, I get 28 grams. And 207 times 1 is 207.19 grams. When I add all these together, I will get the molar mass of lead 2 nitrate, 207.19, plus, it's going to double check my math, 16 times 6 is 96, yes, 60 plus, yes, the 96 plus 28, and then I get 331 point, well, I'm going to just say 331.2 grams per mole of lead 2 nitrate. And what they want to know is how many moles is in 0.250 grams. So I take my given, I'm going to put the work up here now that I found my molar mass. I'm going to take my given, which is 0.0250 grams of lead 2 nitrate, and I'm going to multiply it times 1 mole of lead 2 nitrate over 331.2 grams. And what I'm going to get